Look closely at this small, unassuming piece of polished rock crystal. It was unearthed from the dust of an ancient Assyrian palace, a relic from a world that existed nearly 3,000 years ago. To the untrained eye, it might seem like a simple decorative object, perhaps a piece of inlay from a long-forgotten piece of furniture. But what if this artifact, known as the Nimrud Lens, is something far more extraordinary? What if you are looking at evidence of advanced optical science from an era we have always considered primitive? Could this 3,000-year-old object be the world's oldest known telescope, a device that predates the accepted invention of the telescope by millennia? This single object, small enough to fit in the palm of your hand, challenges the very timeline of human innovation and invites us on a journey to rewrite history. The story of the Nimrud Lens is a deep and captivating mystery, one that takes us back to the heart of the mighty Assyrian Empire, a civilization of immense power and sophistication. Discovered by the renowned archaeologist Sir Austen Henry Layard in the 1850s at the ancient site of Nimrud, in what is now Iraq, the lens has been a subject of quiet fascination and heated debate ever since. Its existence forces us to ask profound questions. Who crafted it and for what precise purpose? Was it the treasured tool of a brilliant royal astronomer, used to map the heavens with a clarity never before imagined? Or does its secret lie in more practical, earthly applications, a magnifying glass for delicate artisans or a tool to start fires? The true answer has been lost to the sands of time, leaving behind only this enigmatic crystal and a puzzle that has teased historians and scientists for generations. In this video, we are going to become investigators. Together, we will sift through the evidence, explore the compelling theories, and separate plausible fact from captivating fiction. We will journey into the world of the Assyrians, understanding their remarkable achievements in art, engineering, and science to see if the creation of a functional lens fits within their worldview. We will examine the lens itself, its precise craftsmanship and optical properties through the eyes of modern physicists, and we will confront the bigger, more thrilling question. If this was indeed our optical instrument, what does that mean for our understanding of ancient technology? It is a story of what might have been, a glimpse into a forgotten chapter of human genius. So, join me as we unravel the enigma of the Nimrud Lens and explore one of history's most intriguing and overlooked secrets. So let's get a clearer picture of this mysterious object itself. Currently residing in a display case at the British Museum in London, the Nimrud Lens is a small, ground piece of rock crystal, also known as quartz. It measures roughly 38 millimeters in diameter, which is about the size of a large coin, and it's just over 22 millimeters thick at its center. If you were to hold it, you'd notice it isn't a perfect circle. It has a slightly oval shape, suggesting it was crafted to fit a specific setting or mount. The most remarkable feature is its surface. One side is convex, carefully polished into a gentle dome, while the other side is flatter. This is not a naturally occurring shape. The crystal has been deliberately ground and polished to form a lentil-like profile, which is where we get the word lens from. When experts tested its optical properties, they found it has a focal length of about 12 centimeters, meaning it can focus sunlight to a point at that distance and magnify objects quite effectively. Its discovery was as dramatic as its implications. It was found by the pioneering archaeologist Austen Henry Layard in 1850 during his excavations of the northwest palace of King Ashurbanipal II at Nimrud. It lay buried amidst the spectacular ivories and other treasures of the palace, a humble-looking object surrounded by grandeur which only adds to its intrigue. To understand the significance of this find, we need to step back into the world of the 1840s, a time when the great empires of the ancient Near East were little more than whispers in the dust, mentioned in the Bible but lost to the physical world. It was into this vacuum of knowledge that a young, ambitious Englishman named Austen Henry Layard arrived. Driven by a sense of adventure and a keen intellect, Layard began excavations at the mound of Nimrud in 1845, convinced it hid the ruins of the biblical city of Nineveh. He was partially mistaken about the name, but spectacularly correct about its importance. What he uncovered was the ancient Assyrian capital of Kalhu, a city of staggering scale and opulence. With a relatively small team and limited resources, Layard's work was nothing short of heroic. He unearthed colossal winged bull statues, intricate bas-reliefs depicting royal lion hunts and military conquests, and vast palace complexes that spoke of an empire with immense power and sophisticated artistry. The world was captivated. These discoveries suddenly gave form and substance to a civilization that had until then been largely mythical, pulling the Assyrians from the pages of scripture and into the light of history. It was amidst this breathtaking haul of treasures that the lens was found. The specific context of its discovery is crucial to the mystery. It wasn't uncovered in a common trash pit or a simple home. It was located within the Northwest Palace, the royal residence of King Ashurbanipal II, one of the most formidable rulers of the Assyrian Empire. This palace was the administrative and ceremonial heart of the kingdom around the 9th century BCE. The lens was found in a room that has been interpreted by some as a storage chamber, tucked away amongst a dazzling collection of finely carved ivories. These ivories themselves were often imports or tributes, demonstrating the far-reaching trade networks and influence of the Assyrian court. Imagine the scene through Layard's eyes, workers carefully brushing away millennia of dirt to reveal exquisite artworks, and there, amongst them, this small, oddly shaped piece of crystal. It would have been easy to overlook. In an excavation yielding monumental sculptures and gold, a tiny, cloudy rock crystal doesn't immediately scream revolutionary technology. Unsurprisingly, the initial interpretation leaned towards the decorative. The prevailing thought was that this polished crystal was an ornamental inlay. Perhaps it was meant to be set into a piece of luxurious furniture, maybe a throne or a cabinet, where it would catch the light alongside other precious stones. It could have served as a kind of decorative boss on a shield or a piece of royal regalia. This was a perfectly logical assumption. The Assyrians were master craftsmen, renowned for their detailed and opulent artwork. A polished stone used for adornment fit neatly into the established understanding of their culture. There was no existing framework, no historical precedent, that would lead a 19th century archaeologist to first consider it as a scientific instrument. The very idea of a lens existing in the ancient world was, at that time, almost unthinkable. So, the object was catalogued, its potential true function unrecognized, and it was essentially shelved as a curiosity, a minor artifact overshadowed by the grandeur that surrounded it. For decades, its secret remained dormant, waiting for a shift in perspective that would come much later. So when exactly does this mysterious object enter the historical stage? Through careful analysis of the archaeological layer in which it was found, the Nimrud Lens has been firmly dated to a very specific and fascinating window of time, between approximately 750 and 710 BC. This places it squarely within the Neo-Assyrian period, an era when the empire was at the absolute peak of its power and influence. This isn't just a random date, it's a crucial piece of the puzzle that gives us the cultural and intellectual backdrop against which we must judge its purpose. We're not talking about a primitive, fledgling society. This was a superpower of the ancient world, a civilization with the administrative complexity of a modern state and a thirst for knowledge that reached for the heavens. To grasp the full weight of this, picture the world of the 8th century BC. In Greece, the city-states were just beginning to form. Rome was little more than a collection of villages. But in Mesopotamia, the Assyrian Empire was a colossus. It stretched from the Persian Gulf to the borders of Egypt, a vast territory controlled through military might, sophisticated bureaucracy, and cutting-edge technology for its time. This was the age of kings like Tiglath-Pileser III and Sargon II, ruthless leaders, but also great builders and patrons of the arts and sciences. The capital city of Nimrud, known then as Kalhu, was a thriving metropolis, a cosmopolitan center where goods, ideas, and scholars from across the known world would have converged. The royal court was not just a seat of power, it was a hub of intellectual activity. This context is vital because it shatters the notion that such an object would be anachronistic. The Assyrians were brilliant engineers. They built massive aqueducts and intricate canal systems. They were master astronomers, meticulously recording celestial events on clay tablets, viewing the movements of planets and stars as messages from their gods. Their need for precise timekeeping for religious festivals and administrative purposes led to advanced calendrical systems. In such an environment, the idea of a craftsman experimenting with crystal to magnify tiny cuneiform script for a scribe, or an astronomer seeking a clearer view of the night sky, moves from the realm of fantasy into the distinctly plausible. This was a society that had both the technical skill to grind and polish a lens and the intellectual curiosity to find a use for it. The date of the lens doesn't isolate it as a bizarre outlier. Instead, it plants it firmly in a fertile ground where innovation was not just possible, but actively encouraged by the state. This period of Assyrian history provides the perfect setting for a story of scientific discovery, making the lens not a mysterious aberration, but a potential, logical product of its time. With the object's physical characteristics and its royal context in mind, we can now turn to the most grounded and widely accepted explanation for its existence. The simplest theory, and often the most probable, is that the Nimrud lens was a magnifying glass, a practical tool used by the master craftsmen of the Assyrian court. Imagine the scene within the palace workshops. Artisans would have been engaged in creating some of the most exquisite and delicate objects of the ancient world. Among their most remarkable creations were cylinder seals. These were small, roller-like pieces of stone, often no larger than a human thumb, which were intricately carved in reverse. When rolled across a soft clay tablet, they would leave behind a raised, detailed impression that served as a signature, a form of authentication, or a depiction of religious scene. The level of detail required for this work is almost unimaginable. We're talking about scenes with figures, animals, cuneiform script, and complex patterns all compressed into a tiny surface area. Performing such fine work, especially under the variable light of an ancient workshop, would have been incredibly straining on the eyes. A simple magnifying lens would have been an invaluable aid, allowing an artisan to see the minute lines they were carving with much greater clarity and reducing errors. This theory extends beyond seals to other delicate tasks, such as inlaying furniture with tiny pieces of ivory or semi-precious stones, or even for fine metalworking. It transforms the lens from a mysterious object into a practical, almost mundane tool of the trade, something that would have been indispensable for achieving the level of perfection we see in Assyrian art. The optical properties of the lens itself provide strong, tangible support for this magnifying glass hypothesis. When scientists examined the lens, they determined it has a focal length of approximately 12 centimeters. This is a very practical distance for close-up work. An artisan could hold the lens at that distance from a small object, and it would project a magnified image. While the magnification might be relatively modest, perhaps around 2 to 3 times the original size, that level of enlargement would be more than sufficient to make a significant difference when working on something as minute as the cuneiform characters on a seal. Furthermore, the lens is made of rock crystal or quartz, a material known for its clarity and durability. Unlike glass, which can contain bubbles and impurities that distort the image, high-quality rock crystal can be ground to produce a remarkably clear viewing surface. The fact that it was found in a room with other precious materials, like intricately carved ivories, strengthens the connection to a workshop setting. It could have been part of a craftsman's toolkit, perhaps stored safely in the palace when not in use. This practical application requires no leap of faith in terms of ancient technology. The Assyrians demonstrably had the ability to grind and polish hard stone to precise shapes, as evidenced by their seals and gemstones. Creating a lentil-shaped object with a convex surface is a logical extension of those existing lapidary skills. It doesn't demand a radical rethinking of their scientific knowledge. It simply suggests a clever, practical application of skills they already possessed. However, even within this seemingly straightforward theory, there are nuances and questions that prevent it from being an open and shut case. For instance, if the lens was a common tool for artisans, why have we only found one? One would expect to find more examples, even if they are fragmentary, if magnifying glasses were a standard part of an artisan's equipment. Its discovery in a royal storage room, rather than in the remains of a workshop, also leaves some room for interpretation. Was it a special, high-quality tool reserved for the most skilled craftsmen working directly for the king? Or does its unique context hint at a more specialized purpose? Another point of consideration is the slight oval shape of the lens. While it could have been shaped to fit into a specific handle or mount, it does deviate from a perfect circle, which might suggest its optical perfection was not the absolute highest priority for its maker. These details don't invalidate the magnifying glass theory, but they introduce a layer of complexity. They remind us that while this is the most logical explanation, the complete story of this particular object may hold additional secrets. It forces us to consider that its journey from the hands of a craftsman to a palace storeroom might have been more particular than we can now reconstruct. But beyond the workshop, a far more celestial and controversial theory beckons, one that elevates the lens from a tool of earthly craft to an instrument of heavenly observation. This idea was brought into the spotlight by the Italian scholar Giovanni Pettinato in the 1970s. Pettinato proposed something that, at first glance, seems to belong to the realm of science fiction, that the Nimrud lens was not merely a magnifier, but the key optical component in a simple yet functional telescope. His hypothesis directly challenges the conventional timeline of scientific discovery, suggesting that Assyrian priests or astronomers might have been gazing at the stars with magnified clarity more than 2,000 years before the telescope's official invention in 17th century Europe. To understand why this isn't as far-fetched as it might sound, we need to appreciate the Assyrians' profound and sophisticated relationship with the night sky. For them, astronomy was not an abstract science, it was a vital form of divine communication. They believed the gods expressed their will and foretold the future through celestial omens, the movement of planets, the appearance of comets, and the subtle patterns of the stars. The accuracy of their astronomical records, meticulously inscribed on thousands of clay tablets, is astounding. They could predict lunar eclipses and track the complex paths of planets with remarkable precision. Pettinato argued that such detailed observations would have been significantly easier and far more accurate if viewed through an optical aid. A simple refracting telescope, constructed by placing the lens in a holder of some kind, could have magnified the apparent size of the moon or brought the wanderings of a planet like Jupiter into sharper focus. This wouldn't have been a powerful instrument by modern standards, but even a slight magnification could have provided a critical advantage, allowing priests to detect finer details and make more reliable predictions for the king and the state. In this light, the lens transforms from a craft tool into a possible instrument of immense religious and political power, a device that gave its user a privileged channel to the gods. The mechanics of such a device would have been elegantly simple. A telescope, in its most basic form, requires just two primary components: an objective lens to gather light and form an image, and an eyepiece lens to magnify that image for the viewer. Pettinato suggested that the Nimrud lens could have served as the objective. All that would have been needed was a tube, perhaps made of wood, leather, or even a hollowed-out reed, to hold the lens at one end and block out stray light. The eyepiece could have been another, smaller lens, or perhaps the user would simply peer through the tube, utilizing the single lens to gather more light and provide a clearer, though not highly magnified, view. This isn't about creating a complex piece of machinery rivaling Galileo's telescope. It's about a simple optical enhancement. The Assyrians certainly had the materials and the craftsmanship to assemble such a basic device. The greatest barrier isn't technical but conceptual. Did anyone in the 8th century BC possess the revolutionary idea that polished crystal could extend human vision towards the heavens? Pettinato's theory posits that they did, and that the evidence has been lying in a museum drawer all along. However, this thrilling hypothesis faces significant and legitimate scientific skepticism. The most pressing objection concerns the optical quality of the lens itself. Modern analysis shows that while the lens can focus light, it suffers from noticeable imperfections. It is not a perfect convex shape, and it contains natural inclusions and bubbles within the quartz crystal. These flaws would cause significant optical aberrations, distorting the image and creating a blurry, unfocused view. Critics argue that looking at a star through such a lens would likely produce a messy, indistinct smudge of light, hardly an improvement over the naked eye. Furthermore, the lens's relatively short focal length would necessitate a very compact telescope, which might not have provided a practical viewing experience. Could these distortions have been mitigated by an ancient astronomer, perhaps by using only the very center of the lens where the curvature is most consistent? A slightly clearer image could be achieved. But the question remains whether the marginal benefit would have been worth the effort. The debate essentially boils down to a clash of perspectives. Is the lens just too crude to have been a serious astronomical tool, or does its very existence, with its intentional lenticular shape, prove that the Assyrians were experimenting with optics and that this object represents a primitive yet groundbreaking first step? So we arrive at the core of the scientific puzzle, setting aside the romantic possibilities and focusing cold, hard light on the lens itself. What do its actual physical properties tell us about its intended function? To answer this, we need to turn to the analyses conducted by optometrists and physicists, experts who specialize in how light behaves. Their examinations have revealed an object that is both intriguing and frustratingly imperfect. The lens does indeed have magnifying capabilities. It can focus parallel rays of light to a point about 12 centimeters away. However, the quality of that focused image is the central point of contention. The rock crystal from which it was made is not optically pure. It contains natural bubbles and inclusions that scatter light. More significantly, the grinding process left the lens with an irregular surface. It is not a perfect, smooth sphere but has a somewhat uneven curvature. When you look through it, these imperfections cause significant optical aberrations. The image you see is not sharp and clear, it's blurry and distorted, especially around the edges. For a modern scientist, this is a poor quality lens. If you were to try to use it in a simple telescope, the view of the moon would likely be a fuzzy, ill-defined blob, perhaps even less distinct than what you could see with your unaided eye. This is the strongest argument against the telescope theory. The lens, in its current state, simply may not be good enough to provide any meaningful astronomical advantage. Yet, this conclusion isn't necessarily the final word. We must consider the lens not as a finished product from a modern factory, but as a 3,000-year-old artifact. What we see today is its weathered state. Its surface may have been clearer and more precisely polished when it was first crafted. Tiny scratches and erosion from millennia buried in the earth could have degraded its optical performance. Furthermore, we have to ask about the intent of the maker. Was this lens intended to be a high-precision astronomical instrument, or was it a first attempt, a prototype? Perhaps the Assyrian craftsman who made it was experimenting, discovering the basic principles of optics through trial and error. The very fact that someone shaped a piece of crystal into a convex form demonstrates an understanding that such a shape could bend light. Even if the resulting image was blurry, the phenomenon itself would have been magical and worthy of further investigation. It's possible that this particular lens was a rejected attempt, or one of many, with its flaws leading the maker to discard it or use it for a less demanding purpose. The debate, therefore, isn't just about what the lens is, but what it represents. Does its existence point to a developed optical technology, or does it signify the very beginnings of optical exploration? This leads us to a fascinating middle ground, a theory that bridges the gap between the practical magnifier and the celestial telescope. What if the lens's primary use was for fire starting? This idea, while simple, is remarkably compelling. A convex lens is an excellent tool for concentrating solar energy. By holding the lens at its focal point, 12 centimeters from a pile of dry tinder, an ancient priest or scribe could easily generate a small, intense point of heat enough to ignite a flame. In many ancient cultures, fire held profound religious significance. The ability to create fire from the sun, to literally capture a piece of the sun god's power, would have been a powerful ritual act. This theory elegantly explains why such an object would be found in a royal palace context. It wouldn't be a common workshop tool, but a specialized ritual object, perhaps used in specific ceremonies by the king or high priests. This purpose is perfectly compatible with the lens's optical imperfections. You don't need a perfectly clear, aberration-free image to start a fire. You only need to concentrate light to a hot spot. The lens's quality is more than sufficient for this task. This application grants the object a status and importance that aligns with its fine spot, while also acknowledging the Assyrians' known fascination with the sun and other celestial bodies. It transforms the lens from a mere magnifying glass into a potential instrument of sacred power. Ultimately, the scientific analysis leaves us with a spectrum of possibilities, each with its own merits and weaknesses. The evidence strongly suggests it was not a high-quality telescope lens by any modern standard. However, it was clearly a functional optical device. The most balanced view is to see the Nimrud Lens as a multi-purpose tool, whose specific use may have depended on the context and the user. For an artisan, it was a magnifier. For a priest, it could have been a firelighter or a ritual object. For a curious scholar, it might have been a fascinating toy for experimenting with light. This multifaceted interpretation respects the object's complexity better than trying to force it into a single category. The true enigma of the Nimrud Lens may not be a simple, "What was it?" but a more profound, "What could it have been to the people who held it?" Its value lies in the questions it forces us to ask about the nature of innovation and the sometimes hazy line between practical tool, scientific instrument, and sacred object in the ancient world. Yet for every compelling theory, there is an equally strong voice of skepticism, a perspective that urges caution against rewriting history based on a single, ambiguous artifact. The mainstream archaeological view, while acknowledging the lens's intriguing shape, often dismisses the more dramatic interpretations as wishful thinking. Their argument begins with a simple but powerful point: a lone lens does not make a telescope. A functional astronomical instrument requires a system, typically an objective lens to gather light and an eyepiece to magnify the image it forms. We have no evidence of a second lens, no fragments of a tube, no artistic depictions, and no written records from Assyrian cuneiform tablets that even hint at the concept of magnified vision. In the entire archaeological record of Mesopotamia, the Nimrud Lens stands entirely alone. This isolation is a massive stumbling block. If the Assyrians had developed such a revolutionary technology, wouldn't we expect to find more examples, or at least some echo of its existence in their vast and meticulous archives? Its uniqueness makes it look more like an anomaly, a curious one-off, rather than a piece of widespread technology. Skeptics also question whether its optical properties are even intentional. Could the lenticular shape be a coincidence? The Assyrians were master lapidaries, experts at polishing and engraving hard stones. It is entirely possible that this piece of rock crystal was being fashioned as a decorative inlay, perhaps for a piece of jewelry or furniture, and its slight convexity was simply a product of the polishing process, a shape that was aesthetically pleasing or made it easier to set into a metal fitting. In this view, its ability to focus light is an accidental byproduct, not the purpose of its creation. The observed magnification and focal point might be nothing more than a happy accident of craftsmanship, something the maker may have noticed but never thought to exploit scientifically. After all, many polished stones can slightly bend light. That doesn't mean they were all designed as lenses. This school of thought often circles back to the initial, more mundane interpretation that it was a burning glass. This is seen as the most plausible middle ground. A burning glass is a practical tool, but it doesn't require the sophisticated theoretical understanding of optics that a telescope implies. Using a lens to start a fire is a straightforward application of a visible phenomenon concentrating sunlight to create heat. It aligns with known ritual practices across ancient cultures where fire, especially fire kindled from the sun, held deep symbolic power. This explanation grants the object a special, perhaps even sacred, status that justifies its presence in a royal palace, without needing to invoke an advanced and otherwise invisible scientific tradition. The skeptic's case is ultimately one of Occam's razor. The simplest explanation, the one that requires the fewest assumptions, is probably the correct one. A decorative inlay or a ritual fire starter fits comfortably within our established understanding of Assyrian culture. A revolutionary optical instrument, on the other hand, demands that we tear up the history books based on very fragile evidence. This brings us to what many consider the most elegant and plausible explanation, one that connects the lens directly to a fundamental force of nature, fire. The idea of the Nimrud Lens as a burning glass is remarkably compelling because it aligns so perfectly with both the object's physical capabilities and the known practices of the ancient world. A convex lens is at its heart a superb concentrator of solar energy. By simply holding the lens steady at its focal point, about 12 centimeters above a handful of dry leaves or tinder, a priest or royal attendant could harness the power of the sun to generate a tiny, intensely hot spot of light, capable of producing smoke and then flame in a matter of moments. This wasn't just a party trick. In an era before matches or lighters, the ability to reliably create fire was a cornerstone of civilization. But for the Assyrians, fire was far more than a practical tool for warmth or cooking. It held profound religious and ceremonial significance. The sun itself was worshipped as the god Shamash, the divine judge who brought light and truth to the world. To kindle a flame directly from a beam of sunlight would have been seen as a powerful ritual act, a direct communion with the divine, a way of capturing a fragment of the god's own essence. This theory elegantly explains why such an object would be curated within the royal palace. It wouldn't be a common workshop tool, but a specialized ritual object, perhaps used by the king or high priests in specific ceremonies to light sacred fires, an act that would legitimize their rule by demonstrating their unique connection to the gods. When we look across the ancient world, we find that the Assyrians were far from alone in this understanding of optics. The use of burning glasses is actually well documented in other contemporary cultures, providing a strong comparative context that makes the hypothesis even more credible. The ancient Greeks, for instance, wrote about such devices centuries later. Aristophanes, in his play The Clouds, written in the 5th century BCE, comically references a character using a transparent lens to melt a wax tablet, proving the concept was widely understood. More famously, the legend of Archimedes using a vast array of bronze shields or mirrors to set fire to Roman ships during the siege of Syracuse, though likely apocryphal, shows that the principle of concentrating sunlight for pyrotechnic purposes was a part of the classical imagination. Even earlier in ancient Egypt, there are depictions and artifacts suggesting the use of polished concave mirrors made of copper or bronze to focus sunlight. These parallels are crucial. They demonstrate that the knowledge that curved, reflective or refractive surfaces could create fire was not an isolated discovery but a recurring innovation in the ancient world. The Nimrud Lens, then, would not be an inexplicable anomaly but a Mesopotamian example of a known technological principle, crafted from the material they had mastered, beautifully polished stone. This proposed use also perfectly sidesteps the main criticism leveled against the telescope theory, optical quality. For starting a fire, the lens's imperfections are almost irrelevant. You don't need a perfectly clear, aberration-free image. You only need to concentrate a sufficient amount of thermal energy into a small area. The natural bubbles and slight irregularities in the rock crystal surface would have a negligible effect on its ability to heat a target. In fact, the lens's properties are ideally suited for this task. Its size provides a large enough surface area to gather ample sunlight, and its focal length is practical for a user to hold and maneuver. This application transforms the lens's perceived flaws from a mark against its sophistication into a non-issue. It could have been an incredibly effective and reliable tool, perhaps even more so than other methods like friction-based fire starting, which required significant skill and effort. The burning glass hypothesis presents the Nimrud lens as a clever, efficient, and powerful technology, one that fits seamlessly into the technological and cultural landscape of its time without requiring a radical reinterpretation of ancient science. It grants the object a clear, important, and even sacred purpose, finally offering an answer that feels both historically grounded and satisfyingly significant. But what if the lens's true purpose was not to magnify the physical world, but to peer into the spiritual one? To understand this possibility, we must immerse ourselves in the Assyrian mind, a world view where the boundary between the natural and the supernatural was thin, and where divine will was not an abstract concept but a daily, tangible force that governed everything from state policy to personal fortune. For the Assyrians, the future was not a mystery to be accepted, but a code to be deciphered, and their priests were the master cryptographers. They practiced a sophisticated and all-encompassing system of divination, seeking signs from the gods in the entrails of sacrificed sheep, in the flight patterns of birds, and most profoundly, in the unwavering movements of the celestial bodies. The sky was a divine text, and astronomy was the sacred science of reading it. This opens a fascinating and less tangible theory for the Nimrud lens, that it was a ritual object, a tool for divination or scrying, used to interpret the messages of the gods with enhanced clarity. Consider the practice of extispicy, the examination of a sacrificed animal's liver. A priest, known as a baru, would meticulously inspect the organ's lobes, markings, and anomalies, comparing them to detailed clay models that served as interpretive guides. Every bump, color variation, or unusual shape held a specific meaning, a direct omen from the gods concerning an upcoming military campaign, the king's health, or the fate of the harvest. Now, imagine the advantage a simple magnifying lens would provide in such a ritual. The ability to see tiny, subtle discolorations or vascular patterns invisible to the naked eye could have been the difference between a correct and an incorrect prophecy. In the hands of a high priest, the lens would not be a mere magnifier. It would become a sacred instrument that granted privileged access to the divine will, a technological edge in the most high-stakes activity of the state. Its presence in the royal palace would be perfectly explained not as a workshop tool, but as a key piece of ritual paraphernalia, stored safely alongside other objects of immense spiritual power. This concept extends beyond internal organs to the heavens themselves. Assyrian astronomers, who were also priests, kept incredibly precise records of celestial events on cuneiform tablets known as the enigma Anu Enlil. They believed that the gods communicated their displeasure or favor through eclipses, comets, and the relative positions of planets. A lens, even one with minor optical flaws, could have served a crucial function here. While it may not have provided the sharp image required for a telescope, it could have been used as a sky clarifier. Holding the lens up to the eye would not magnify the stars significantly, but it could act as a simple filter, reducing the twinkling effect caused by atmospheric turbulence. This would make the steady light of the planets appear more stable and distinct against the backdrop of the fainter stars, allowing for more precise tracking of their movements. In a culture where the appearance of the planet Mars in a certain constellation could dictate whether an empire went to war, any tool that offered a clearer, more stable view of the heavens would be an instrument of immense political and religious power. We can also venture into the more speculative realm of scrying, the ancient practice of gazing into a translucent or reflective object to receive visions or prophecies. Cultures across the world have used crystals, mirrors, and pools of water for this purpose. A polished piece of rock crystal, with its unique light-gathering properties and internal, cloud-like inclusions, would have been a perfect focal point for such a practice. A priest might have gazed into the depths of the lens rather than through it at an object. The play of light within the crystal, the distortions created by its imperfections, could have been interpreted as shifting images or symbols sent by the gods. The lens itself, as an object made from a rare and beautiful material believed to hold spiritual energy, would have been considered inherently magical. Its function would be less about optical physics and more about serving as a conduit for divine communication. This interpretation transforms the lens from a scientific tool into a purely ritual one, an object whose value lay not in what it revealed of the physical world, but in the hidden truths it was believed to unlock from the spiritual realm. Ultimately, the ritual and divination theory provides a powerful framework that reconciles the lens's physical properties with its prestigious archaeological context. It doesn't require the lens to be optically perfect. Its imperfections might have even enhanced its mystical appeal. It explains why such an object would be a singular find. A sacred ritual tool would be rare by its very nature, not mass-produced like common workshop implements. This theory allows the Nimrud lens to be exactly what it appears to be, a special, revered object carefully crafted and stored in the heart of royal power because it offered a unique window into the divine intentions that shaped the fate of an empire. But to truly appreciate the Nimrud lens, we must attempt the nearly impossible, to step into the workshop of the artisan who created it. The challenge of grinding a functional lens from rock crystal in the 8th century BC is a story of craftsmanship that borders on the miraculous. Rock crystal, a form of pure quartz, is one of the hardest materials known to the ancient world, ranking a 7 on the Mohs scale of mineral hardness. To put that in perspective, it's harder than iron or copper. So, how did an Assyrian craftsperson, without modern powered tools or diamond-tipped abrasives, manage to shape and polish this stubborn material into such a precise, convex form? The answer lies in a deep, accumulated knowledge of lapidary arts, the working of stone that the Assyrians had perfected over centuries. Their primary method would have been a patient, labor-intensive process of grinding using a slurry of abrasive powder. They likely used sand, which contains quartz particles almost as hard as the crystal itself, or even more effective, powdered emery, a naturally occurring rock rich in corundum, which is even harder. This abrasive powder would be mixed with water or oil to create a grinding paste. The artisan would then have taken a rough piece of rock crystal and, using a tool like a flat stone or a copper disc, begun the slow process of grinding down the surface, constantly adding the abrasive slurry. To achieve the convex curve, they might have employed a technique called lapidary grinding, where the stone is worked against a concave surface, or perhaps they used a freehand method, rocking the crystal against the grinding stone in a circular motion to wear it down evenly into a dome. The final, brilliant polish would have been achieved with progressively finer abrasives, perhaps using a soft leather pad and a paste made from something like tin oxide or even finely ground pumice, painstakingly rubbing the surface until it achieved the desired clarity and smoothness. This was not a quick process. It would have required an immense amount of skill, a superb understanding of materials, and a degree of patience that is almost unimaginable today. The creation of the lens was a testament to the fact that for these master artisans, time was not a constraint, perfection was the only goal. The tools available to them, while simple by our standards, were remarkably effective in skilled hands. The Assyrian artisan's toolkit would have included bow drills for boring holes, saws with abrasive-coated blades for cutting stone, and a variety of chisels and gravers made from hardened copper or bronze. For a task like shaping the lens, the most crucial tools were the grinding wheels or stones. Archaeological evidence suggests they used simple, rotary devices. Imagine a horizontal stone wheel turned slowly by a bow or a crank mechanism. The artisan would hold the rock crystal against the spinning wheel, which was continuously fed with the abrasive slurry. This setup would allow for a more controlled and consistent grinding action than purely manual methods. They also had access to lathes, which could have been used to hold the workpiece and rotate it against a stationary tool, ensuring a symmetrical shape. What's truly astounding is the level of precision they could achieve without any of our modern measuring instruments. They judged the curvature and thickness by eye and by feel, their expertise so refined that they could sense minute variations in the surface. This was a knowledge passed down through generations, a deep, intuitive understanding of material behavior that we can only admire from a distance. The creation of the Nimrud Lens was not an accident. It was the product of a highly advanced craft tradition operating at the very peak of its capabilities. This leads us directly to the next profound question. Was this lens a singular, fluke creation, or is it a rare surviving example of a more widespread technology? The fact that we have only found one such lens is both puzzling and significant. If lens making was a common practice, we would expect to find more examples, perhaps broken fragments in workshop remains, or others set into jewelry or tools. Its uniqueness has led many to argue that it was indeed a one-of-a-kind object, an experimental piece created by a particularly brilliant and curious artisan. Perhaps this craftsperson noticed that a polished, curved piece of crystal could make objects appear larger while working on a decorative inlay, and decided to explore the phenomenon further. In this scenario, the lens is a prototype, a brilliant dead end in technological history whose potential was never fully realized or disseminated. Its value might have been seen as purely curious or even magical, and the knowledge of how to create it may have died with its maker. However, an equally compelling argument suggests that its uniqueness is an illusion created by the ravages of time. Organic materials like the wood or leather handles it might have been mounted in have long since decayed. Other lenses could have been made from glass, which is far more fragile than rock crystal, and would have crumbled to dust over 3 millennia. Furthermore, we have only excavated a tiny fraction of the ancient Assyrian world. The vast majority of their cities, and certainly their workshops, remain buried. It is entirely possible that the Nimrud Lens is not unique at all, but simply the only one that has survived intact and been recognized for what it is. The Assyrian Empire was a vast, interconnected state with standardized technologies and centralized production. If lens grinding was a known skill, it would likely have been a specialized trade, practiced by a small number of master craftsmen serving the royal court. Their products would have been rare and valuable, not everyday items. The loss of a single workshop to fire or invasion could have erased the technology from the record. Therefore, the Nimrud Lens might be a precious clue, a solitary survivor pointing to a lost chapter of optical science that was more advanced than we have ever dared to imagine. Its very existence, regardless of how many were made, is proof that the concept of a lens was not only understood but actively manufactured with intent, pushing the boundaries of what we thought possible in the ancient world. Now, to truly grasp the place of the Nimrud lens in history, we must widen our gaze beyond the palaces of Assyria and consider a fascinating possibility that it was not alone. While it remains the most famous and thoroughly studied example, it is not the only ancient lens to have been unearthed. Scattered across the archaeological record of the Bronze Age and classical world are other, often older, objects that tell a similar, fragmented story of early optical experimentation. Perhaps the most astonishing of these comes from the island of Crete, from the magnificent Minoan palace of Knossos. Here, archaeologists discovered a collection of rock crystal lenses, but these are not from the 8th century BC like the Nimrud lens. They date back to around 2000 BC, a staggering 1,200 years earlier. These Minoan lenses were found in a context that hints at a very specific and sophisticated use. They were intricately fashioned into the eyes of exquisite composite statues, likely of goddesses or worshippers. The craftsmanship is breathtaking. The lenses are expertly ground and polished, and some were even drilled to be held in place by rivets. Their purpose was clearly artistic and perhaps symbolic, meant to give the statues a lifelike, gleaming gaze. But the very fact that Minoan artisans over 3 millennia ago had mastered the technique of creating clear, curved crystal discs speaks volumes. It proves that the knowledge required to shape optical quality rock crystal was not an Assyrian invention, but a technology that had been developed and lost and perhaps rediscovered across the ancient world. Venturing into Egypt, we find more tantalizing clues. While no single Egyptian lens has gained the fame of the Nimrud specimen, there are strong indications that the principles of optics were understood. The most compelling evidence comes not from a lens but from a reflection. A hieroglyphic text from the 11th century BC describes a ritual instrument called a menat, which some scholars have interpreted as a possible polished metal mirror used for focusing sunlight. Furthermore, the Egyptians were unparalleled masters of jewelry and stoneworking. They carved intricate amulets from the hardest stones and inlaid eyes into statues with materials like crystal and obsidian. It is almost inconceivable that, in their relentless pursuit of perfection, these master craftsmen did not notice the magnifying properties of curved, transparent stones. While a definitive Egyptian telescope is pure speculation, the idea that they used simple magnifying aids for fine work, such as detailing miniature scarabs or reading minute hieroglyphs on seals, is a very reasonable assumption. Their artistic output itself serves as indirect evidence. The incredible precision of their smallest carvings often seems to demand some form of optical assistance to achieve. When we line up these disparate finds, the Minoan crystal eyes, the potential Egyptian tools, and the Nimrud lens, a pattern begins to emerge, albeit a faint and broken one. They are separated by vast distances and centuries, yet they share a common thread: the application of advanced lapidary skills to create objects that manipulate light. The differences, however, are just as telling. The Minoan lenses were primarily decorative, integrated into art. The Nimrud lens, with its fine spot away from statuary, suggests a more utilitarian or ritual purpose. This variation is crucial. It implies that this knowledge of optics was not part of a unified, formal science, but rather a practical craft technique that was discovered and applied independently by different cultures to solve different problems. A Minoan artisan wanted to make a statue's eyes gleam. An Assyrian craftsperson may have wanted to magnify a tiny seal or start a ritual fire. The underlying principle, grinding crystal into a convex shape, was the same, but the application was dictated by local need and culture. This leads us to the central, haunting question raised by these comparisons. Do these scattered lenses represent nothing more than isolated incidents, lucky accidents of craftsmanship? Or do they point to a more widespread but now almost entirely lost body of knowledge? The isolated incident theory is the safer, more conservative view. It suggests that each culture stumbled upon the basic idea independently while polishing stones for other reasons, used it for a limited purpose, and that the technology never evolved beyond a niche craft secret because there was no theoretical framework to support it. It remained a trick of the trade, not a science. The evidence for this is the sheer scarcity of finds. If lens grinding was common, we would have found more. But the other possibility is far more thrilling. Perhaps these few surviving lenses are the last surviving whispers of a forgotten technological tradition. Think of the vast span of time between the Minoan lenses and the Nimrud lens over a millennium. Think of the empires that rose and fell, the libraries burned, the workshops destroyed. The archaeological record is incredibly sparse. We have recovered only a tiny fraction of what once existed. It is entirely plausible that the grinding of lenses was a more widespread practice than we can now prove. This knowledge could have been passed along trade routes from Minoan Crete to the Near East, or discovered anew by brilliant minds in different eras. The fact that the best examples we have come from royal or religious contexts suggests this was specialized, valuable knowledge, not commonplace. Its loss would have been easy. A change in artistic fashion, the death of a master artisan without an apprentice, the destruction of a capital city, any of these could have severed the thread of transmission. The Nimrud lens, therefore, might not be an anomaly, but a rare and precious survivor, a single piece of a gigantic puzzle that is mostly missing. It stands as a powerful reminder that history is not just the story of what survived, but also a silent testament to the immense volume of knowledge and innovation that has been irrevocably lost to time. This singular artifact, however, is not the only mysterious object from this region that seems to defy our conventional timelines. To appreciate the full weight of the Nimrud lens's mystery, we must consider it alongside another equally perplexing discovery from ancient Mesopotamia, the so-called Baghdad Battery. Found in the 1930s just outside the Iraqi capital, this object consists of a simple clay jar, roughly 13 centimeters tall, which contained a copper cylinder, and within that, an iron rod. The components were held in place by an asphalt plug, which also served as a seal and showed signs of corrosion from an acidic substance like vinegar or wine. When reconstructed by modern experimenters, this simple setup was found to be capable of generating a small electrical charge, around 1 volt. The immediate and tantalizing question was obvious. Had the Parthian civilization, which existed around 2,000 years ago, stumbled upon the principles of electrochemistry? The debate surrounding the Baghdad Battery mirrors the one we see with the Nimrud lens in a fascinating way. On one side, skeptics offer perfectly reasonable alternative explanations. They suggest the jar was merely a storage container for sacred scrolls, with the iron and copper rods simply being the core around which the parchment was wrapped, and the acidic residue a result of the scroll's decomposition. They point out that no wires or associated electrical devices have ever been found, and that a single volt of electricity seems too minuscule to have any practical application. The mainstream view, therefore, dismisses the electrochemical interpretation as an attractive but ultimately unproven fantasy. Yet, proponents of the battery theory counter with compelling possibilities. They argue that a small electrical charge, while weak by our standards, could have had significant uses in the ancient world. One of the most cited experiments demonstrated that several of these jars linked together could produce enough current to electroplate a thin layer of gold or silver onto a small object, a technique known as gilding. This would explain the existence of exquisitely gold-plated artifacts from the period that show no signs of hammering or heat application. Alternatively, the mild shock could have been used for medicinal or religious purposes, perhaps as a form of primitive electrotherapy or to create a mysterious tingling sensation during temple rituals, enhancing the perceived power of a priest. When we place the Nimrud Lens and the Baghdad battery side by side, a provocative pattern begins to emerge. We have two distinct artifacts separated by several centuries but born from the same fertile crescent of human civilization, each suggesting a grasp of a fundamental natural force, light and electricity, that we do not traditionally associate with the ancient world. Both objects are unique or nearly so, making them easy to dismiss as anomalies. Both have plausible, mundane explanations that fit comfortably within established archaeological understanding. But what if their true significance lies not in proving a specific use, but in pointing to a broader cultural trait? What if they are not proof of a developed technology, but rather evidence of a spirit of experimentation? This leads us to a profound and unsettling question that challenges the very foundations of our historical narrative. Could it be that ancient societies, particularly in Mesopotamia, possessed a level of curiosity and proto-scientific exploration that we have consistently underestimated? We are quick to acknowledge their achievements in astronomy, mathematics, and engineering, but we often relegate their science to the theoretical or the observational. The existence of objects like these suggests something more hands-on. They hint at a culture where artisans and scholars were not just recording the world, but actively probing its secrets, tinkering with materials to see what they could make them do. The act of polishing a crystal and noticing it bends light, or of assembling copper, iron, and acid and feeling a strange new sensation, represents a form of practical inquiry. It is the very essence of the scientific method, albeit in its most embryonic form. Perhaps we have been looking at these artifacts backwards. Instead of asking, did the Assyrians have telescopes, or did the Parthians have batteries? Questions that demand a level of technological integration we cannot prove, we should be asking a different, more revealing question. What does the existence of these objects tell us about the ancient mind? They are powerful testaments to human ingenuity and innate curiosity. They suggest that the drive to understand and manipulate the natural world is not a modern invention but a timeless human impulse. The Nimrud Lens and the Baghdad battery may not be proof of lost high technology, but they are almost certainly proof of lost experiments. They are the silent, fragmentary evidence of countless trials and errors, of brilliant ideas that were perhaps never fully developed, or whose development was lost in the cataclysmic collapses of empires. They remind us that history is not a simple, linear progression from primitive to advanced, but a complex story with fits and starts, with periods of brilliant innovation that flickered brightly before being extinguished, only to be rediscovered millennia later. To truly understand who might have used the Nimrud Lens, we must step away from the workshop and enter the world of the Ashurbanipal, a figure far more than a simple priest. In the complex hierarchy of Assyrian society, the Ashurbanipal was a scholar, a physician, an exorcist, and an astronomer all rolled into one. These men were the intellectual elite, the keepers of a vast and secret knowledge that bridged the gap between the tangible world and the divine. Their primary role was to diagnose and combat the sources of misfortune, which were almost always seen as supernatural in origin: the anger of a god, the attack of a demon, or the curse of a sorcerer. To do this, they relied on an extensive library of cuneiform tablets containing omens, medical recipes, and complex rituals. They were, in essence, the scientists of their day, operating within a framework where every natural event, from an illness to an eclipse, was a message to be decoded. Imagine the Ashurbanipal at work, hunched over a clay tablet covered in minute cuneiform signs, consulting a medical text that lists symptoms and corresponding herbal cures. The script is incredibly dense and small, a challenge for even the sharpest eyes. Here, a simple magnifying lens would have been an invaluable tool, not for crafting but for reading. It would allow the scholar to decipher tiny, critical details in the ancient texts without straining his vision, ensuring that a ritual was performed with perfect accuracy or a medicinal dose was measured correctly. A single misread character could mean the difference between a healing potion and a poison, between appeasing a god and invoking further wrath. In this context, the lens becomes an instrument of precision for the most high-stakes intellectual work, amplifying the Ashapu's ability to access and apply the accumulated wisdom of his civilization. Their responsibilities extended far beyond the library walls and into the very heavens. As master astronomers, the Ashapu priests were tasked with maintaining the celestial watch, scanning the night sky for any deviation that might signal a divine omen. They recorded the movements of planets and stars on tablets with meticulous care. While the lens may not have been powerful enough to see the moons of Jupiter, it could have served a more subtle purpose. By holding the polished crystal to the eye, it could have acted as a simple filter, reducing the distorting twinkle of the atmosphere and making the steady light of a planet like Venus or Mars appear clearer and more distinct against the backdrop of fainter stars. This clearer view would have allowed for more precise tracking of a planet's path through the constellations, a critical factor in interpreting its astrological meaning. In the hands of an Ashapu, the lens transforms from a piece of rock crystal into a key for unlocking the messages of the gods written across the night sky. But their most direct interaction with the supernatural came through the practice of extispacy, the examination of a sacrificed animal's liver. This was a cornerstone of Assyrian statecraft. Before any major decision, a military campaign, the coronation of a king, a sheep would be sacrificed and its liver carefully removed. The Ashapu would then examine the organ, comparing its shape, color, and any unusual markings to detailed clay models that served as interpretive guides. Every bump, discoloration, or anomaly in the lobes and ducts held a specific prophetic meaning. Now, consider the advantage a magnifying lens would provide in this sacred, high-pressure ritual. The ability to see tiny vascular patterns or subtle discolorations invisible to the naked eye could reveal a more nuanced omen, offering the king a more precise reading of the divine will. In this scenario, the lens is no longer just a tool. It is a sacred instrument that enhances the priest's perception, granting him unparalleled access to the intentions of the gods. Its power lies not in its magnification, but in the authority it confers upon the user. This blend of the practical and the mystical defines the Ashapu. They were men of learning who used tangible tools to navigate an intangible world. A device like the Nimrud Lens fits perfectly into their arsenal. It could have been used to examine a suspect amulet for tiny inscriptions of a curse, to better observe the flight of birds for divination, or even to focus sunlight during a ritual to kindle a sacred flame from the sun god Shamash. Its value would have been immense precisely because it served multiple functions across their diverse duties. The lens's discovery in a royal palace storage room, among other precious items, strongly suggests it was not a common tool but a specialized instrument belonging to someone of high status. The Ashapu, as a trusted advisor to the king, fits this profile perfectly. He would have been one of the few individuals in the empire with the knowledge to appreciate such an object's potential and the authority to possess it. The enigma of the Nimrud Lens finds its most compelling resolution not in a single purpose, but in the multifaceted world of these scholar priests, for whom seeing more clearly, whether a text, a star, or a liver, was synonymous with understanding the very forces that shaped their universe. To fully appreciate the significance of an object like the Nimrud Lens, we must transport ourselves to the intellectual heart of the Assyrian Empire, a place that has been called the greatest library of the ancient world before the rise of Alexandria. This was the royal library of Ashurbanipal, established in the city of Nineveh by the last great king of the Neo-Assyrian Empire. Ashurbanipal was a ruler unlike any other. While his predecessors were celebrated primarily as warriors and conquerors, He proudly declared himself a man of letters, a scholar king who could read the complex cuneiform script of the Sumerians and Akkadians. A skill he boasted was a secret even to most of the royal scribes. Driven by an insatiable thirst for knowledge, he dispatched agents to every corner of his vast empire with a singular mission: to collect, copy, and bring back to Nineveh every scroll and clay tablet of importance they could find. The result was a repository of human understanding so vast that its rediscovery in the 19th century fundamentally reshaped our entire understanding of Mesopotamian civilization. Imagine the scale of this endeavor. The library wasn't a single room, it was a vast complex of chambers within the royal palace, filled from floor to ceiling with tens of thousands of clay tablets. These weren't just dry administrative records, though there were plenty of those. This was a deliberate, systematic compilation of the entire known corpus of knowledge. There were epic poems like the Epic of Gilgamesh, which had been lost to humanity for millennia. There were detailed legal codes, complex grammatical texts, and intricate musical scales. But most importantly for our mystery, there were entire sections dedicated to what we would call science. The library housed thousands of tablets on astronomy, recording celestial movements with painstaking precision. There were medical texts describing symptoms, diagnoses, and sophisticated herbal remedies. There were mathematical tablets detailing quadratic equations and geometric principles used for engineering and land surveying. This was not a haphazard collection. It was a centralized university of the ancient world, a place where the brightest minds of the empire could access the sum total of its accumulated wisdom. It is within this vibrant context of intense, state-sponsored scholarly pursuit that the Nimrud Lens suddenly appears not as an oddity, but as a perfectly plausible tool. When you picture the scholars of Ashurbanipal's court, the Ashurpu priests, the royal astronomers, the master mathematicians huddled over these tiny, densely inscribed cuneiform tablets, the need for an optical aid becomes immediately apparent. The script is incredibly small and complex, a forest of wedge-shaped marks where a single misread character could change the entire meaning of a medical prescription or a celestial omen. A simple magnifying lens would have been an invaluable instrument for these men, protecting their eyesight and ensuring absolute accuracy in their critical work. The library itself provides the perfect environment for such a device. This was a culture that revered knowledge, that went to extraordinary lengths to preserve and systematize it. In such an environment, the creation of a tool to better access that knowledge is not just possible, it is almost expected. The lens stops being a mysterious artifact and starts to look like a natural extension of the Assyrian drive for precision and understanding. Furthermore, the advanced nature of the texts found in the library directly supports the more ambitious theories about the lens's use. The astronomical tablets, for instance, are not simple star charts. They contain precise records of planetary movements, lunar cycles, and even predictions of eclipses. To achieve this level of accuracy, the Assyrian astronomers needed to make incredibly fine observations. Could they have done it all with the naked eye? Almost certainly. But would a tool that offered even a slight clarification have been seized upon by these meticulous scholars? It seems highly likely. The idea that a lens could have been used as a sky clarifier to reduce atmospheric twinkling and make a planet's position more distinct fits perfectly with the obsessive precision we see in their records. The library proves that the intellectual curiosity and the methodological rigor were already in place. The lens could have been the practical instrument that complemented their theoretical prowess. The library of Ashurbanipal thus shatters the argument that advanced optical technology would be anachronistic for this period. It provides the missing cultural backdrop. We are not talking about a primitive society stumbling upon a strange rock. We are talking about a sophisticated, literate, and scientifically engaged civilization that was actively exploring the boundaries of knowledge in every field. The creation of a lens is a feat of lapidary skill, and the Assyrians demonstrably had that skill. Its use as a scientific instrument requires a culture of inquiry, and the library is overwhelming proof that such a culture flourished. The loss of the library itself, destroyed when Nineveh fell in 612 BCE, also helps explain why the lens appears so unique. The vast majority of Assyrian knowledge, along with who knows how many other specialized tools, was lost in that cataclysm. The Nimrud Lens, then, might not be a lone wonder, but a single, incredibly rare survivor from a world of innovation that was almost entirely obliterated. It is a tangible fragment that hints at the sophisticated tools that must have existed within the halls of Ashurbanipal's great library, tools that were used by scholars to measure the heavens and document the world with a clarity that would not be seen again for centuries. This gap between historical speculation and practical reality is precisely where modern investigators step in, armed not with ancient texts but with tools and a determined curiosity to test these theories with their own hands. Across the world, historians, physicists, and enthusiastic hobbyists have taken on the challenge of recreating the Nimrud Lens, grinding their own pieces of rock crystal to its exact specifications to see what it can truly do. Their experiments provide us with something invaluable, tangible, empirical data that moves the discussion beyond abstract debate and into the realm of demonstrable function. So, what happens when you actually look through a faithful replica of this 3,000-year-old object? One of the most straightforward tests involves its potential as a magnifying glass. Researchers have found that an accurately recreated lens does indeed possess a clear magnifying power. When held at its focal length of about 12 centimeters from a surface, it can enlarge small text or intricate details by approximately 2 to 3 times. This may not sound like much compared to a modern magnifier, but for a craftsperson working on something as minute as the cuneiform script of a cylinder seal, the difference would be significant. It transforms a blur of tiny wedges into distinguishable marks, reducing eye strain and potentially increasing the precision of the work. This experiment strongly validates the theory that the lens could have been an invaluable tool in an artisan's workshop. The effect is immediate and practical, proving that even with its imperfections, the lens performs this basic task effectively. However, testers also confirm the limitations noted by scientists. The image is not perfectly sharp. The natural flaws in the quartz and the slight irregularities in the convex surface cause distortions, especially around the edges of the viewing area. For close-up work, a skilled user would likely learn to use the clearest central part of the lens, mitigating this issue to a large degree. The fire-starting experiment is perhaps the most dramatic and conclusive. Using a replica lens on a sunny day, modern experimenters have consistently demonstrated that it can ignite dry tinder in a matter of seconds. The process is simple. The user angles the lens to catch the sunlight, focusing the beams into a small, brilliant point on a pile of char cloth or dried leaves. Within moments, smoke appears, followed by a glowing ember that can be gently blown into a flame. This test is incredibly successful and removes any doubt about the lens's efficacy for this purpose. The optical aberrations that make it poor for viewing are completely irrelevant for generating heat. All that matters is concentrating solar energy, and the lens excels at this. This practical result lends enormous weight to the ritual burning glass theory, as it confirms the object's functionality in a way that aligns perfectly with known ancient practices. It transforms the lens from a speculative object into a powerful and reliable tool, a piece of technology that works exactly as intended. But the most ambitious experiments involve the telescope theory. Here, the results are far more mixed and reveal the true challenges of ancient optics. Researchers attempting to use a replica lens as the objective in a simple telescope have encountered the problems predicted by skeptics. When paired with a modern eyepiece to create a basic refractor, the lens does produce a magnified image of a distant object, such as a faraway tree or building. This in itself is a remarkable feat, proving the fundamental principle that such a device could be constructed. However, the quality of that image is extremely poor. The optical aberrations cause severe blurring and chromatic distortion, meaning colors fringe and the image lacks sharp definition. Viewing the moon, for instance, results in a fuzzy, ill-defined bright patch rather than a clear disk with craters. The question then becomes not could it be done, but would it be useful? Most experimenters conclude that the view through such a primitive telescope would offer little to no advantage over the naked eye for serious astronomical observation. The distortions are so significant that they likely outweigh any benefit of magnification. Yet, some experimenters have proposed a more nuanced application. What if the lens wasn't used for high magnification viewing, but as a simple light gatherer? By looking through the lens on its own without an eyepiece at a bright planet like Venus or Jupiter, the lens can act as a very mild telescope. It gathers more light than the naked eye alone, making the planet appear as a slightly larger, steadier point of light. The lens's thickness also helps to reduce the atmospheric twinkling that makes stars shimmer, potentially providing a clearer, more stable view for tracking a planet's slow movement against the fixed stars. This would not reveal new details like moons or rings, but it could make the task of precise positional astronomy, so critical to Assyrian divination, somewhat easier. This experiment suggests that while the Nimrud lens was certainly not a telescope in the modern sense, it might have served as a rudimentary optical aid that provided a marginal but meaningful improvement for a dedicated sky watcher. The experiments ultimately paint a picture of a functional, multi-purpose tool. It works well as a magnifier for close work, superbly as a fire starter, and with limited success as a basic optical aid for astronomy. These modern recreations don't give us a single, definitive answer, but they do illuminate the spectrum of possibilities that were available to an ancient Assyrian who held this remarkable piece of crystal in their hand. While the scientific and historical debates around the Nimrud lens are compelling, its story doesn't end in academic journals. This small artifact has been catapulted into the realm of modern myth, becoming a favorite piece of evidence for theories that challenge our understanding of history itself. In the world of alternative history and popular media, the lens has taken on a life far beyond its probable use as a magnifier or fire starter. It has been transformed into a symbol, a key piece of a much larger and more dramatic puzzle, one that often involves lost advanced civilizations or even visitors from the stars. This journey from museum piece to pop culture icon reveals just as much about our own fascinations as it does about the ancient world. Perhaps the most famous framework that has adopted the Nimrud lens is the ancient astronaut theory, popularized by books and television series like Ancient Aliens. In this narrative, the lens is frequently presented as clear-cut evidence of advanced technology that was simply too sophisticated for the people of its time to have invented on their own. The argument goes something like this: since the conventional timeline says the telescope wasn't invented until the 17th century, a functional lens from 3,000 years ago must be an out-of-place artifact, or OOPArt. Proponents then ask a provocative question: if the Assyrians didn't create it, then who did? The answer offered often points to extraterrestrial visitors who provided the technology, or alternatively, to a vastly advanced human civilization like Atlantis, whose knowledge was lost in a great cataclysm. In these stories, the lens is no longer a curious tool. It becomes a fragment of a forgotten global high-tech era, or even a gift from alien mentors to humanity. This interpretation taps into a powerful and appealing sense of mystery, suggesting that our history is far grander and more enigmatic than we've been led to believe. However, when we separate this compelling fiction from the established facts, a significant gap emerges. The core of the alternative argument often rests on a misconception. the idea that the lens is a perfectly crafted, high-precision optical instrument. As we've learned from scientific analysis, this is not the case. The lens is a functional but flawed piece of craftsmanship. Its optical aberrations and imperfections are typically glossed over or ignored in these speculative accounts because a blurry, imperfect lens doesn't fit the narrative of a hyper-advanced technology. Furthermore, these theories rarely engage with the robust historical context we discussed earlier. The advanced state of Assyrian engineering, their sophisticated astronomical knowledge, and their masterful lapidary skills. By presenting the Assyrians as a primitive people incapable of such innovation, the alternative narrative does a great disservice to their very real and impressive achievements. The lens becomes an anomaly only if we underestimate the capabilities of the civilization that produced it. The appeal of these theories is understandable. They offer a more thrilling and romantic version of history, one filled with cosmic mysteries and forgotten secrets. The Nimrud Lens, sitting silently in its museum case, becomes a blank canvas onto which we can project our own wonders and questions about humanity's past. It speaks to a deep-seated desire for there to be more to our story, for lost chapters of incredible technological prowess. This is why the lens features prominently in documentaries that explore the edges of history, in popular science fiction novels, and in countless online forums where enthusiasts dissect every detail. It has become a touchstone for those who suspect that mainstream archaeology is too conservative or that it has missed crucial evidence. Navigating this space requires a careful balance. It is perfectly valid to be fascinated by the unanswered questions surrounding the lens and to wonder about possibilities that extend beyond the most conservative explanations. Healthy skepticism about established narratives can lead to genuine breakthroughs. However, this curiosity must be tempered with a respect for the evidence. The true story of the Nimrud Lens is not necessarily less amazing than the ancient astronaut theory. It is simply amazing in a different way. The reality that a master craftsperson in the 8th century BC could grind a piece of rock crystal to manipulate light is a profound testament to human ingenuity. It reminds us that innovation is not linear and that ancient civilizations possessed a practical intelligence and skill that we are still working to fully appreciate. The lens isn't evidence of aliens or Atlantis. It is evidence of the brilliant, resourceful, and endlessly creative human mind, capable of extraordinary inventions long before we ever thought possible. The ongoing debate over the Nimrud Lens is far more than a simple academic quarrel. It represents a fundamental clash of philosophies about how we understand the past. This divide persists not necessarily because of a lack of evidence, but because the same piece of evidence is viewed through two entirely different lenses, so to speak. On one side, mainstream archaeology operates with a principle often called Occam's razor, the idea that the simplest explanation, the one requiring the fewest assumptions, is usually the correct one. From this vantage point, the lens is most logically a magnifying tool or a ritual burning glass. These explanations fit neatly within the well-documented framework of Assyrian material culture. There's no need to invoke a lost, advanced technology because the existing evidence for their sophisticated craftsmanship and religious practices provides a perfectly adequate context. For these scholars, proposing a function like a telescope requires a cascade of additional assumptions: that there were other lenses, that they were mounted in tubes, that the Assyrians understood the optical principles involved, and that this knowledge was somehow completely erased from the historical record without a trace. The absence of any corroborating evidence, no other lenses, no depictions, no written references, makes this chain of reasoning feel like a house of cards, intriguing but ultimately unsupported. Conversely, more speculative historians and researchers approach the artifact with a different set of priorities. They are often driven by a desire to explore the outermost possibilities of ancient ingenuity. Their methodology is less about finding the simplest fit and more about asking, What if, for them, the uniqueness of the Nimrud lens is not a reason to dismiss it, but a reason to prize it as a rare survivor? They argue that the archaeological record is incredibly fragmentary. We have recovered only a tiny fraction of what once existed. The vast libraries of the ancient world, like that of Ashurbanipal, were mostly destroyed, and countless inventions made of perishable materials like wood and leather have turned to dust. In this light, the lens could be a solitary clue pointing to a broader, but now lost, tradition of optical experimentation. This perspective is less concerned with the lens's optical imperfections and more focused on the intent behind its creation. The very fact that someone deliberately shaped crystal into a convex form demonstrates an understanding of a basic optical principle. Whether it worked perfectly is almost beside the point. The significant fact is that someone was trying. This disagreement is also fueled by a deeper, almost psychological reluctance to rewrite established historical narratives. The timeline of human invention is a cornerstone of our understanding of progress. The telescope is a landmark achievement of the scientific revolution, a symbol of humanity's emergence from a perceived age of superstition into an era of enlightenment. To suggest that a functional optical device existed millennia earlier forces uncomfortable reconsideration of this linear progression. It implies that major leaps in science and technology might not be unique to modern times but can occur, be lost, and be rediscovered. This can be threatening to a worldview that places our civilization at the pinnacle of human development. For alternative historians, this is precisely the point. They see mainstream science as being invested in a narrative of progressive superiority and therefore resistant to evidence that complicates it. They accuse archaeologists of a kind of intellectual conservatism, an unwillingness to consider paradigm-shifting possibilities because it destabilizes the foundations of their field. At its heart, the stalemate reflects a difference in how we value ambiguity. Mainstream archaeology as a science demands a high standard of proof. A single artifact, no matter how intriguing, is considered insufficient evidence to overturn a well-established historical model. It is seen as an anomaly until it can be connected to other finds that form a pattern. Speculative history, on the other hand, often thrives on anomalies. A single, unexplained object is a catalyst for reimagining the entire past, a prompt to fill in the gaps with bold new hypotheses. One side sees a puzzle missing too many pieces to see the picture clearly, while the other side believes that even one strange piece is enough to guess at the image's true, and perhaps more spectacular, nature. The Nimrud lens, therefore, sits at the intersection of these two ways of knowing. It is a test case for how we balance cautious, evidence-based interpretation with the creative, exploratory spirit that also drives discovery. The debate rages on because the lens is a Rorschach test for our own assumptions about antiquity, challenging us to decide whether we see the past as a book whose chapters are mostly known, or as a vast archive where the most exciting volumes may still be missing. These surface imperfections lead us directly to another physical clue, one that might hold the key to how the lens was actually used. The object's edges are smooth and show no obvious signs of being attached to a permanent handle or a rigid frame. There are no drill holes for a rivet, no grooves for a metal setting, no adhesive residue. This absence is deafening. If it was a simple handheld magnifier for a craftsman, one might expect a comfortable handle, perhaps a simple loop of bronze or even a wooden grip that has long since decayed. The fact that it doesn't have one suggests a different kind of use. Perhaps it was meant to be set into something temporarily, or maybe it was handled infrequently and with great care. Consider the possibility that it was designed to be inserted into a pre-made slot on a different object. It could have been part of a larger, more complex instrument. Some researchers have proposed it might have been set into a small, flat board with a hole in the center, creating a stand that could be placed directly over a piece of text or a tiny artifact, allowing the user to view it hands-free. This would be incredibly useful for a scribe copying dense cuneiform or a priest examining a sacrificial liver, freeing both hands for other tasks. Alternatively, the lack of a handle could point towards a more static ceremonial function. If its primary role was as a burning glass for starting ritual fires, it might have been mounted on a simple stand or a ceremonial pole, positioned to catch the rays of the sun at a specific time of day or year. The very fact that it seems designed to be held in a specific way, yet lacks the apparatus for easy handling, deepens the mystery of its daily life in the Assyrian court. This puzzle of the mount forces us to think creatively about the objects that haven't survived. The lens itself, made of durable rock crystal, endured 3,000 years in the ground. But what about the materials that would have accompanied it? Any frame made of wood, leather, or even ivory would have decomposed completely, leaving no trace for the excavators. A simple telescope tube, crafted from a hollowed-out piece of wood or formed from sewn leather, would have returned to the earth centuries ago. This is a classic problem in archaeology. We are left with the durable skeleton of a culture, while the flesh and blood of its everyday objects, the organic parts that completed a tool, are gone forever. The Nimrud Lens might not be a complete artifact. It might be the only surviving component of a more elaborate device. Its true identity could be locked within a wooden casing that rotted away in the damp soil of Nimrud, or a handle that was discarded and lost. This line of thinking opens up a world of possibilities. The lens in its museum case is a silent, incomplete witness. We see the crystal core, but the apparatus that gave it purpose, that turned it from a piece of polished stone into a functional instrument, has vanished. This realization makes the object seem less like a mystery and more like a tragic incompleteness, a single page torn from a vast technical manual. This question of a missing mount inevitably leads us to the single most persistent argument against the Nimrud Lens representing a widespread technology: its profound loneliness. Out of the countless artifacts recovered from Mesopotamian sites, this one piece of ground crystal stands alone. No other lenses have been found in Assyrian palaces, temples, or workshops. For many scholars, this isolation is the most compelling evidence that it was an anomaly, a fascinating fluke, perhaps the result of a single, curious artisan experimenting with a piece of crystal, whose discovery was accidental and whose potential was never understood or replicated. In this view, the lens is a dead end in the history of technology, a brilliant spark that failed to ignite a flame. If lens grinding were a known craft, the reasoning goes, we would expect to find a trail of evidence, failed attempts, broken fragments, or even just more examples. Its singularity makes it look less like a piece of standard equipment and more like a lucky one-off. Yet, this argument rests entirely on the fragile and incomplete nature of the archaeological record itself. We must remember that what we have excavated is a minuscule fraction of what once existed. The vast, sprawling metropolis of Nimrud is still largely buried, and countless other Assyrian cities have barely been touched by archaeologists. More importantly, we are primarily finding what has survived the ravages of time: materials like stone, pottery, and metal. The most likely components of an optical device, however, would have been highly perishable. Imagine a simple telescope, a hollow tube of wood or leather, perhaps with a wooden handle for a magnifier. These organic materials would have decomposed completely in the damp Mesopotamian soil over 3 millennia, leaving no trace whatsoever. The lens itself survives only because it is made of nearly indestructible quartz. It is entirely plausible that the Nimrud Lens is not unique at all, but is simply the only durable component of a technology that was otherwise made from materials that returned to the earth. We are, in effect, trying to reconstruct an entire book from a single page that was printed on stone, while all the paper pages have long since turned to dust. This concept extends to how such a tool would have been used and stored. If lenses were specialized instruments belonging to the intellectual elite, like the scholar priests or royal astronomers, they would have been rare and valuable objects, not common household items. Their number would have been small to begin with. Furthermore, consider the fate of the great Assyrian cities. They were not gently abandoned, they were violently destroyed. The sack of Nimrud and Nineveh involved massive fires and systematic looting. In such chaos, delicate instruments would have been among the first things broken, lost, or carried off as plunder, only to be discarded later when their purpose was unknown to the conquerors. The survival of this one lens, tucked away in a storage room, might have been a sheer accident. The loss of the vast royal library of Ashurbanipal, with its thousands of clay tablets, shows us how easily an entire world of knowledge can be obliterated. The absence of other lenses, therefore, is not proof of their non-existence. It could just as easily be evidence of a technology that was fragile, rare, and tragically vulnerable to the collapse of an empire. We can also look to other cultures for a telling parallel. The Vikings, for instance, are known to have used a navigation tool called a sunstone, a crystal that could polarize light to locate the sun on cloudy days. For centuries, this was just a legend mentioned in sagas with no physical evidence. Then, recently, a candidate crystal was found aboard a sunken Viking ship. It was a single specimen. Does its uniqueness mean the Vikings didn't use sunstones, or does it mean that such tools were precious, few in number, and made of materials that rarely survive? The Nimrud lens may be in a similar situation. Its solitary nature forces us to choose between two interpretations. Either we see it as a curious outlier, a product of chance that signifies nothing broader, or we see it as a rare and precious survivor, a single shimmering clue pointing to a forgotten world of optical exploration that has otherwise vanished without a trace. The choice we make says less about the object itself and more about our willingness to fill the silent gaps of history with possibility. The potential redating of the lens's invention from the Middle Ages back to the Assyrian era would not merely adjust a date in a textbook, it would fundamentally reshape our entire narrative of scientific progress. We tend to envision history as a linear march, a clear progression from primitive understanding to modern enlightenment, with key milestones like the telescope belonging firmly to the scientific revolution of the 16th and 17th centuries. But if the Nimrud lens was an intentional optical instrument, it introduces a powerful element of discontinuity. It suggests that profound insights can be achieved, utilized within a specific cultural context, and then lost for centuries only to be rediscovered later. This challenges the comforting idea of cumulative knowledge, forcing us to consider a much more complex and fragmented history of innovation, where brilliance flares up in isolated pockets rather than burning in a continuous, ever-brightening flame. Consider the established timeline. The first verified eyeglasses appear in Italy in the late 13th century, a development that revolutionized intellectual life by extending the productive years of scholars and artisans. The compound microscope and the telescope emerge in the Netherlands around the turn of the 17th century, instruments that unlock the worlds of the infinitesimally small and the astronomically distant. These are landmark events that we rightly celebrate. The existence of a functional lens over 2,000 years earlier would force us to see these achievements not as absolute beginnings, but as rediscoveries or perhaps independent reinventions. It would mean that the basic principles of refraction were not first grasped in medieval Europe, but were understood and applied in the royal courts of Mesopotamia. This doesn't diminish the accomplishments of Galileo or Leeuwenhoek. Instead, it places them in a broader, more intriguing human story of curiosity, repeatedly stumbling upon the same natural laws across the vast expanse of time. This possibility also forces a reconsideration of the relationship between technology and its surrounding culture. The telescope flourished in Renaissance Europe because it found a fertile ground of patronage, printing presses to disseminate discoveries, and a competitive spirit among nations and thinkers. The Assyrians, for all their sophistication, operated within a different framework, one where knowledge was often secret, reserved for the priesthood and the court, and where technological advances served the state and religion directly. An Assyrian telescope, if it existed, might have been a tool of divination, its use confined to a small elite to read the will of the gods in the stars. Without a culture of open scientific inquiry and widespread communication, the technology may have remained a state secret, vulnerable to being extinguished entirely when the empire collapsed. The lesson here is that an invention requires more than just a brilliant mind. It needs a society capable of nurturing, spreading, and building upon that innovation. The lens's potential obscurity highlights that the survival of an idea is as important as its initial conception. Furthermore, this discovery would compel us to look at other ancient achievements with fresh eyes. The precise astronomical records of the Babylonians, the intricate gearwork of the Antikythera mechanism from ancient Greece, the advanced metallurgy of various cultures, these are often viewed as remarkable but isolated peaks. The Nimrud Lens, if accepted as deliberate, would suggest that these peaks might not have been so isolated. It encourages a perspective where we actively search for the tools behind the achievements. How did ancient astronomers make such precise observations? Perhaps they had aids we haven't yet recognized or that haven't survived. It invites a more generous interpretation of the capabilities of past societies, urging us to consider that their technological toolkit may have been more diverse and sophisticated than the durable remnants of stone and metal in our museums imply. Ultimately, the greatest implication of the Nimrud Lens is that it serves as a profound warning against intellectual arrogance. It reminds us that our current understanding of history is a work in progress, constantly being revised with each new discovery. To dismiss the lens as an anomaly is to assume our historical record is nearly complete. To seriously engage with its possibilities is to embrace the humility that vast chapters of human ingenuity may have been lost, their pages turned to dust. This small piece of rock crystal becomes a symbol of the limits of our knowledge, challenging us to keep looking, to keep questioning, and to remain open to the possibility that the past was far more inventive and the path of science far more winding than we have ever dared to imagine. Now that we have journeyed through the evidence, explored the workshop and the observatory, and considered the lens from every angle, it is time to gather all the clues and weigh them on the scales of plausibility. Let us revisit the four primary theories: the magnifying glass, the telescope, the ritual burning glass, and the divination tool, and assess the strengths and weaknesses of each, building a case based on the facts we have. First, the magnifying glass theory. The case for this is strong and straightforward. The lens demonstrably magnifies, and the Assyrians were master craftsmen producing incredibly detailed work on tiny surfaces like cylinder seals. The need for such a tool is clear, and the technology to create it, advanced lapidary skills, was absolutely within their capabilities. The primary argument against it is the lens's uniqueness. If it was a common workshop tool, why have we not found more? However, this objection is tempered by the fact that it was found in a royal context, suggesting it may have been a high-quality tool for the most elite artisans. On balance, this theory is highly plausible. It requires no leap of faith in technology or culture and solves a genuine practical problem. It is a solid, grounded explanation. Next, the telescope hypothesis. This is the most thrilling but also the most scientifically contentious idea. The argument in its favor rests on the Assyrians' sophisticated astronomical knowledge and their need for precise celestial observations for divination. The possibility that a simple optical aid could have provided an edge is intellectually seductive. However, the case against it is formidable. The lens's optical quality, with its significant aberrations, makes it poorly suited for providing a clear, magnified view of the heavens. Modern recreations confirm that the image would be blurry and distorted. Furthermore, there is a complete absence of corroborating evidence, no second lens for an eyepiece, no traces of a tube, and no mention of such a device in their vast astronomical records. While not impossible, the telescope theory requires us to accept a significant technological achievement that left no other trace in the archaeological record. It sits on the far end of the plausibility spectrum, a captivating what-if that struggles to align with the physical evidence. Then we have the ritual burning glass theory. This explanation elegantly bridges the gap between the practical and the sacred. The lens excels at concentrating sunlight to start a fire, a function confirmed by modern experiments. This practical application is perfectly compatible with the lens's optical flaws, as starting a fire does not require a clear image. Crucially, this theory provides a powerful reason for the object's presence in a royal palace. The ability to kindle fire from the sun god Shamash would have been a potent ritual act, elevating the lens from a simple tool to a sacred instrument of immense symbolic power. The use of burning glasses is also documented in other ancient cultures, providing a welcome comparative context. The main weakness of this theory is that it is difficult to prove definitively, but it faces no significant contradictory evidence. It fits the object's capabilities, its find spot, and the cultural mindset of the Assyrians almost perfectly. Finally, the broader ritual or divination tool theory. This encompasses uses like scrying or as an aid for examining sacrificial livers. The strength here is that it directly connects the lens to the core activities of the Assyrian intellectual elite, the Ashurbanipal priests. A magnifier would have been invaluable for reading tiny cuneiform omens or spotting subtle markings on an animal's liver. This theory explains the object's prestige and rarity. The weakness is that it is less specific. It could easily overlap with the magnifying glass theory, just in a different context. However, it powerfully justifies why such a unique object would be stored in a palace alongside other treasures. So, which theory carries the most weight if we apply the principle of Occam's razor, seeking the simplest explanation that fits all the facts? The ritual burning glass emerges as a remarkably strong candidate. It accounts for the lens's physical properties without demanding perfect optics. It aligns with known ancient practices, and it provides a compelling, prestigious reason for its royal context. The magnifying glass theory is a very close second, equally plausible from a technological standpoint, though it slightly less elegantly explains the singular, curated nature of the find. The divination tool theory can comfortably be woven into either of these explanations. The telescope theory, while capturing the imagination, is burdened by too many scientific and archaeological hurdles to be considered the most likely primary function. Perhaps the most satisfying conclusion is not to choose one single theory, but to recognize that the Nimrud Lens was likely a multi-purpose object. Its value may have lain in its versatility. In the hands of a master jeweler, it was a magnifier. In the hands of a priest at dawn, it was a tool to ignite the sacred fire. For a scholar straining to read a faded tablet, it was a reading aid. This multifaceted interpretation respects the complexity of the artifact better than forcing it into a single category. The true answer is that the Nimrud Lens was not just one thing. It was a testament to human ingenuity, a simple piece of crystal whose meaning was shaped by the need and the wisdom of the person who held it. Despite our deep dive into the possibilities, the Nimrud Lens steadfastly guards its ultimate secret, leaving us with a host of unanswered questions that continue to fuel the debate. The central mystery remains unresolved because the evidence we have is ultimately circumstantial. It strongly suggests what the lens could have done, but falls short of proving what it was used for day after day in the Assyrian court. This is the fundamental challenge of archaeology. We are left with the durable hardware of history, while the software, the specific intentions, the precise hand motions, the spoken instructions has been permanently erased. We can test its optical properties until the end of time, but we cannot ask its owner to demonstrate its purpose. This gap between capability and confirmed use is where the true enigma lies, and it's a gap that future research, armed with ever-advancing technology, may one day be able to bridge. One of the most promising avenues for unlocking this puzzle lies in the realm of microscopic analysis. Modern science possesses tools that Layard and his 19th century contemporaries could not have dreamed of. Imagine subjecting the lens's surface to high-resolution scanning electron microscopy. This could potentially detect minuscule traces of materials that have been all but invisible until now. If the lens was consistently used as a magnifier by a scribe, could there be microscopic residues of clay dust or even the faintest imprint of cuneiform wedges left in the tiny scratches on its surface? If it was employed by a craftsman working with ivory, might we find traces of ancient bone particles or the specific compounds used in adhesives? Perhaps most intriguingly, if it was a burning glass used in ritual contexts, could we detect carbon deposits or the chemical signature of specific tinders that were considered sacred? These are not far-fetched ideas. Residue analysis has revolutionized our understanding of other ancient tools, from identifying the contents of pottery to determining the use of stone blades. A focused, non-destructive examination of the lens at a microscopic level could provide the first direct physical evidence of what this object actually touched, moving the discussion beyond theory and into the realm of forensic fact. Beyond the lens itself, the mystery could be cracked open by a new archaeological discovery. The story of the Nimrud Lens is defined by its solitude, but what if its discovery was merely a preview? The vast majority of the ancient Assyrian world remains buried beneath the sands of modern Iraq. Future excavations at other key sites, perhaps the royal workshops of Nineveh or the temples of Ashur, could uncover another lens. A second specimen, especially one found in a different context, would be a game changer. Finding a lens in a clearly defined workshop area would powerfully support the artisan theory. Discovering one in an astronomical observatory or a priestly quarter would lend immense credibility to the celestial or divination hypotheses. Even a broken fragment could be invaluable, as it might show signs of how it was mounted or handled. The potential for such a find is very real. Archaeology is a field that continually surprises us, and the next turn of a shovel could provide the missing piece that finally solves the puzzle. Furthermore, advancements in digital modeling and virtual reconstruction offer a powerful way to experiment without risking damage to the original artifact. Researchers could create a perfect three-dimensional digital scan of the lens and use physics-based rendering software to simulate how light passes through its exact geometry, accounting for every flaw and inclusion. This would allow for incredibly precise testing of its optical capabilities under various conditions. Scientists could virtually pair it with different types of eyepieces to see if a combination could have produced a usable astronomical image. They could simulate its performance as a burning glass under the specific solar angles of Mesopotamia at different times of the year. This kind of computational archaeology allows for endless experimentation, providing a level of clarity about its functional limits that physical recreations can only approximate. It turns the lens into a data set, and from that data, we can extract a more nuanced understanding of its potential. Ultimately, the enduring fascination with the Nimrud Lens is about more than just identifying an ancient tool. It's about what its true purpose would mean for our narrative of human ingenuity. If it was a simple magnifier, it confirms the Assyrians as pragmatic and brilliant craftsmen. If it was a burning glass, it reveals a deep, symbolic connection between their technology and their religion. But if future evidence ever conclusively showed it was part of an optical instrument for viewing the heavens, it would force a profound shift in our perspective. It would mean that the drive to build tools to extend our senses, a drive we see as the hallmark of the modern scientific age, is not a recent development but a fundamental and recurring thread in the human story. The lens challenges us to be humble, to accept that our current timeline of invention is a work in progress, and to remain open to the possibility that the past was far more inventive than the scattered ruins suggest. The mystery endures not as a failure of science but as an invitation, a call to keep looking, to keep questioning, and to remember that sometimes the smallest objects can hold the biggest secrets, waiting patiently for the right light to reveal them. And so we are left with this small, polished piece of crystal and a mystery that may never be fully settled. But perhaps the true power of the Nimrud Lens lies not in the answer we might one day find, but in the profound questions it forces us to ask. It taps into a deep and universal human fascination with the unsolved, the piece of the puzzle that refuses to fit. There is a certain magic in an object that resists categorization, that stands at the edge of our understanding and whispers of possibilities just beyond our grasp. This isn't about proving aliens or lost super civilizations. It's about the simple, thrilling acknowledgement that the past is not a book we have fully read, but an archive where entire chapters are still missing. The lens is a tangible link to one of those missing chapters, a permanent question mark etched in stone that challenges the neat and tidy timeline of human progress we so often take for granted. This allure is rooted in something fundamental within us, a deep-seated curiosity about our own story. We have an innate desire to map the journey of human ingenuity, to trace a clear line from the first stone tools to the silicon chip. We find comfort in this narrative of continuous advancement, but an artifact like the Nimrud Lens disrupts that comfortable narrative. It presents us with an anomaly, a spike on the graph of technology that seems to appear out of nowhere. It forces us to confront the uncomfortable idea that history might not be a smooth, upward slope, but a landscape of peaks and valleys where brilliant ideas can flare into existence and then be lost for centuries. The lens is a monument to a potential path not taken, a glimpse of an alternate history of science that makes the past feel suddenly larger, more complex, and far more mysterious than we imagined. This mystery also captivates us because it is a story about the fragility of knowledge. The Assyrian Empire was a colossus with vast libraries, centralized administration, and master craftsmen. Yet, when its cities fell, that immense body of knowledge was scattered, burned, or buried. The Nimrud Lens is a stark reminder of how easily entire technologies can vanish. It represents not just what the Assyrians might have known, but all the other innovations, great and small, that were lost in the collapse of empires, the burning of libraries, and the simple passage of time. It stands as a silent witness to the countless experiments, ideas, and skills that have disappeared without a trace, making us wonder what other secrets are still hidden beneath the dust, waiting to challenge our assumptions. Ultimately, the enduring fascination with the Nimrud Lens is a testament to the power of a single object to ignite our imagination. It invites everyone to become an investigator, to weigh the evidence, and to draw their own conclusions. Whether you see it as a master artisan's magnifier, a priest's sacred firelighter, or the first step toward a telescope, the lens sparks a conversation across the centuries. It doesn't just belong to archaeologists and physicists, it belongs to anyone who has ever looked at an ancient artifact and felt a sense of wonder. It reminds us that history is not a closed case but a living, breathing dialogue between the past and the present, and that sometimes the most humbling and exciting thing we can say is, we don't know for sure. In that space of uncertainty, in the gap between what is proven and what is possible, lies the true and lasting magic of this enigmatic crystal. So where does this long investigation leave us? After exploring the dusty chambers of the Assyrian palace, peering through the lens ourselves with modern science, and weighing the compelling arguments from scholars and skeptics alike, we find ourselves not with a single, definitive answer, but with a richer, more complex appreciation for the mystery itself. The Nimrud Lens resists a simple label. It stands as a powerful testament to the fact that the past does not always yield its secrets easily, and that some artifacts are valuable precisely because they challenge our assumptions. On one hand, the evidence points strongly towards practical, earthly uses. The theory that it was a magnifying glass for master artisans carving intricate cylinder seals is deeply persuasive. It aligns perfectly with the Assyrians' known lapidary skills and solves a genuine problem faced by anyone working on a miniature scale. The ritual burning glass theory is equally compelling, offering a sacred purpose that explains its royal context and connects it to the powerful sun god Shamash. Both of these explanations are satisfying because they are grounded, logical, and fit neatly within the world we understand the Assyrians to have inhabited. They require no radical rewriting of history, only a recognition of their sophisticated craftsmanship and symbolic thinking. On the other hand, the more revolutionary idea that it was an early optical instrument, a prototype for a telescope, continues to capture our imagination. While the scientific hurdles are significant, the lens's imperfections and the lack of corroborating evidence are substantial obstacles. The possibility alone is thrilling. It forces us to consider that the spark of scientific curiosity, the drive to extend human vision, may have flickered much earlier than our textbooks tell us. Even if it wasn't a successful telescope, the very act of shaping the crystal demonstrates an engagement with the principles of light, a first step on a path that would be rediscovered millennia later. Perhaps the most honest conclusion is that the Nimrud Lens was all these things and none of them exclusively. Its true power may have been its versatility. In the hands of a jeweler, it was a practical aid. For a priest at a dawn ceremony, it was a tool for divine connection. For a curious scholar, it might have been a fascinating object of experimentation. Its meaning was not fixed in the crystal itself, but in the needs and the intellect of the person who held it. This multifaceted nature is what makes it so enigmatic and so profoundly human. It reflects a world where the boundaries between science, art, and religion were fluid, and a single object could bridge them all. Ultimately, the lens is a reminder of the immense gaps in our knowledge. The archaeological record is not a complete library, but a collection of scattered, fire-damaged pages. The vast majority of what the Assyrians created, especially from organic materials like wood and leather, has vanished forever. The Nimrud Lens survives as a rare, durable clue, a single whisper from a forgotten conversation about light and vision. It challenges the linear narrative of progress, suggesting that history is not a smooth climb but a story of discoveries made, lost, and remade. This small, unassuming piece of rock crystal, therefore, is far more than an ancient tool. It is an invitation. It invites us to question, to wonder, and to remain humble in the face of the past's complexity. It prompts us to look at other ancient achievements with fresh eyes, to ask what other ingenious solutions and lost technologies might be waiting just beneath the surface, hidden in plain sight. The mystery endures, and in that uncertainty lies its enduring power to fascinate and inspire. What do you think the Nimrud Lens truly was? A magnifier, a sacred fire starter, or something even more extraordinary? Share your own theories and thoughts in the comments below. And if you enjoyed unraveling this ancient enigma with me, be sure to subscribe. There are countless more historical mysteries waiting to be explored.